This chapter starts with section 1, which is all about single product break-even analysis. Break-even analysis is sometimes referred to as cost, volume, profit analysis because it's about the relationship between sales, volume and profit. Most businesses need to at least break even when they set their selling prices and output levels, and what that means is that they need to cover all of their costs, and that means all of their variable costs and also their fixed costs. Now, in break-even analysis, we make some assumptions, and these are firstly that the selling price per unit is going to be constant. In other words, it's not necessary to reduce selling price in order to sell more units. The second assumption is that the variable cost per unit is constant. So that means that there are no bulk purchase discounts and every single unit we buy is going to cost us exactly the same. And the fixed costs in total are also going to remain constant. So there are no stepped costs, and at all levels in what we call the relevant range, the fixed cost is going to be the same. Now, what that means is that we can actually look at linear relationships for volume and sales revenue. In other words, we could plot them if we wanted to on a straight line as a graph, and we also describe that as perfect competition. Okay, in section 1.5, there's quite a lot of formulae that you need to learn. It looks like there's a lot there, but actually once you get to grips with the main principles of these formulae, then they can quite easily be adapted for what you need to use them for. The first one we'll look at is the break-even point. Now, this formula will give you a break-even point in terms of units. So how many units do you need to sell in order to completely break even? That means there's no profit or no loss, but you've covered all your fixed costs and your variable costs. So what we do is we take our total fixed costs and we divide that by the unit contribution, which remember is the selling price minus the variable cost. And that will give us the break-even point in units. Now, sometimes we may want to know what is the break-even revenue. Now, the break-even revenue we could get just by multiplying the break-even point in units by the selling price per unit, and that would give us the break-even revenue. But there's actually a quicker way of getting to this if we use something called the contribution to sales ratio. Now, the CS ratio is exactly what it says on the tin. What it does is it takes our contribution per unit and divides it by the selling price per unit. So for example, if something sold for $1 and the contribution was 50 cents, then that would be a 0.5 CS ratio. All we need to do then to get to the break-even revenue is take our fixed cost in total, as before, and this time divide it by that CS ratio. Now, underneath there, we've got another formula which will tell us how much we need to actually make in order to get a level of target profit. Now, if the normal break-even point formula will tell us how much we need to cover just fixed costs, all we need to do is add on the amount of target profit to essentially increase the amount that needs to be covered by our unit contribution. So think of that one as the contribution required, and it's effectively the same as the first formula. And finally, we've got the margin of safety. Now, the margin of safety tells us how much room we've got before we start to make a loss. And it's the difference between our budgeted sales and our break-even sales. And we can work that out in terms of units. It's more useful to actually express the margin of safety as a percentage. So if we actually take that unit figure and work it out as a percentage of our budgeted sales, that will effectively tell us what percentage our sales can fall by before we start to make a loss. Let's have a look at applying some of these in lecture example 1. So XYZ company sells a single product for which data is given below. So we've got selling price of 15, variable cost of 9, and fixed cost per unit is 3. And the fixed costs are based on a budgeted level of activity of 7,500 units for the period. We've got some sentences that we're going to have to complete. So the first thing I'm going to do here is I'm going to work out the total fixed cost. And if they used 7,500, if we multiply that by 3, the total fixed cost would be $22,500. So let's look at the first sentence. XYZ needs to make number units in order to break even. If the fixed cost increased by 50%, they will need to have a margin of whatever percent. So we need to fill in the blanks there. So first thing to work out is the break-even point. We know that the break-even point is going to be our total fixed costs divided by the contribution per unit. Now I've just worked out the total fixed costs here, $22,500. The contribution per unit is 15 minus 9, which is 6. So 22,500 divided by 6 gives me 3,750 units in order to break even. So we can fill that in there. Now, if fixed costs increase by 50%, then they're going to go up to $33,750. Now that means that there's going to be a new break-even point. So contribution hasn't changed, and that will now be 5,625 units. We're after the margin of safety. Remember, the margin of safety is our budgeted units minus our break-even units as a percentage of our budgeted units. So here we've got 7,500, which is what we're budgeting. We've got 5,625, which is our new break-even. And as a percentage of 7.5, that gives me 25% margin of safety. So our sales can fall by 25% before we make a loss. Okay, so next we're going to look at the number of units they need to sell in order to make a profit of 9,000 for the period, assuming that fixed costs don't increase. So we're going to assume fixed costs are still 22.5. So remember, we're looking for the required contribution. And that required contribution is going to be enough to cover fixed costs and also now 9,000 target profit. So we need 3,500 in total. The contribution per unit is still 6. So we need to sell 5,250 units in order to hit that level of profit. And then finally, if variable costs increase by 10%, selling price goes up by 20 and fixed costs stay the same, the percentage change in the number of units in order to achieve the required level of profit is going to be whatever percent. So let's have a look at this one. We've got a few workings to do here first. We need to work out what the new level of cost is going to be for the variable cost. So that was going to increase by 10%. So that will now be $9.90. The selling price, 15, is going to go up by 20%. So that will go up to $18. And therefore the new contribution is going to be 18 minus $9.90, which will be $8.10. Now we need to know how many units are going to reach that target profit. So remember, 31.5 was the amount of the fixed cost and the 9,000 target profit. If we now divide that by $8.10, we end up with 3,889. Notice that I've rounded up there, and you always need to round up in break even. If we sell 3,888, we won't quite have covered it. So the percentage change is going to be the difference between what we did have to sell, which was 5,250, and 3,889 as a percentage of 5,250. And that comes to 26%. A serious limitation of break-even analysis is that we can only use it for one product, a single product. So in section 2, we're going to look at something called multi-product break-even analysis. Now what we can do is we can expand this analysis for a single mix of products using a weighted average contribution figure. For this to work, we've got to be working with a constant mix of products. Now, there are a couple more formulae for you to learn here. Don't get too worried though, because they're very, very similar to what we've seen before. The only difference is that for our break-even point, so this is to work out the break-even point in units, all we're going to add is the weighted average unit contribution instead of just the unit contribution. And for the break-even revenue, to work that out in dollars, we're literally just going to add the weighted average CS ratio instead of just the CS ratio. Lecture example 2. Unit Trading sells 3 products as follows: footballs, baseballs and rugby balls. And they sell them in a certain mix, and the mix is always fixed. We can see that we've got budgeted sales of 2,000, 4,000 and 3,000, and that ratio of 2 to 4 to 3 is essentially the mix that they're talking about there. The fixed costs are $20,000 in total, and we've also been given the selling price and the variable costs of each of the products. So the first thing we're going to do is work out the multi-product break-even point. So we need to take the total fixed costs and divide that by the weighted average contribution. So the way we're going to do this is start off by working out the individual contributions for each of the products. So let's take footballs. Footballs have got a selling price of 7 and a variable cost of 3, so the contribution is 4. Baseballs, 6 and 4.50, so that's $1.50. And rugby balls, 9 and 5, which is also 4. So in order to work out the weighted average contribution, we're just going to take the 4 and multiply it by 2. Now we could have multiplied it by 2,000 because there's actually 2,000 footballs, but if we just lose the zeros, it makes the calculation a little bit more straightforward. So we've got 4 multiplied by 2, we've got 1.5 multiplied by 4, and we've got 4 multiplied by 3. And we're going to divide that over the total in the whole of the mix, which is 9,000, or we'll just use 9. Now if we do that, we end up with 2.889, and that's the weighted average contribution. So the break-even units is just our fixed costs, $20,000, divided by 2.889, and that gives us 6,923 units. Okay, so we know that the break-even point is going to be when we sell 6,923 units, but what we haven't found out yet is how they are going to be split across the 3 different products. Now all we do is we literally just prorata them according to the mix. So if we take our footballs, we're going to take 2/9 of 6,923, and that gives us 1538 footballs. If we do the same for baseballs, using 4/9, 3077, and for rugby balls, using 3/9 is 2308. So that all comes back to 6923. In part B, we need to work out the break-even revenue. So the easiest way to do this is going to be to just multiply what we've done already by the selling price. So the footballs are 7, so that comes to $10,766. Our baseballs sell for 6, and that comes to $18,462. And finally our rugby balls are 9, and that comes to $20,772. So that's a total of $50,000 in revenue to break even, and 6923 units. Now in the exam you're not going to have to draw a break-even graph right from scratch, but you may be asked to interpret or to put labels or indicate areas on a graph. So to actually draw one from scratch is a really good way of getting to grips with that. So we're going to look at that in lecture example 3. We're going to put together a break-even chart for the detail that we had in lecture example 1 about the footballs, the baseballs and the rugby balls. What we've got are some partially completed workings, and we're going to finish those off in order to help us draw this graph. Now, to draw a break-even graph, what we need to do is we need to have 2 lines. And one line is going to be for total revenue, and the other line is going to be for total costs. So where they intersect is going to be the break-even point, the point where total revenue and total costs are equal. So let's start off with the total revenue. Now we're going to plot this as a total mix, so we need to know how much revenue is going to be earned when they actually sell all of their budgeted 9,000 units. So 2,000 units multiplied by 7 is going to be 14,000. 4,000 multiplied by 6 is 24, and 3,000 multiplied by 9 is $27,000. So in total that comes to $65,000. Now we only need 2 points in order to draw a straight line, so don't forget these are linear relationships. So it makes sense to use 0. So when we don't sell anything, we won't get any revenue, and the budgeted amount of 9,000 units. And when we sell 9,000 units, we're going to get a total revenue of $65,000. So let's put that line onto the break-even chart. Okay, so this is the multi-product break-even chart. Up the y-axis, we've got costs and revenues. And on the x-axis, we've got the output volume in units. So let's draw on the total revenue line. Now we said that we've got 2 points. The first is 0, and the second is when we actually sell 9,000 units. So that's going to be about there, and 65,000 is going to be there. So let's label that line as total revenue. Okay, now on to total cost. So let's look at variable cost first. So we need to multiply these variable costs out by the numbers of units. So 2,000 times 3 would be 6,000. 4,000 times 450 is 18,000. And 3 times 5 will be 15,000. So that's a total variable cost of 39,000, but don't forget that we've also got fixed cost of 20,000. So the total cost is actually going to be 59,000 when we sell 9,000 budgeted units. So once again, let's use that as one plot point and use 0 as the other. Now this time our line is not going to start from 0, and the reason for that is because of the fixed costs. The fixed costs are going to be incurred even if we don't sell any units. So we're actually going to have our line starting from $20,000. And at 9,000 units, it's going to be 59, which is about there. So we can draw that line on and label that total cost. Okay, so that's that line. Now, where they intersect is our break-even point. So what we should be able to do is read down to the bottom, and that should be our break-even point. Now, because of the scale, it's not going to be exact, but that you can see is in the area of 6923. We should be able to also read this across, and our break-even revenue is $50,000. Now in the exam you might be asked to actually indicate what certain parts of the graph actually mean. So let's have a look to see what might happen here. This area down here is the margin of safety. It's the difference between what they're budgeting to sell, which is 9,000 units, and the break-even point of 6923. This distance here is actually the profit. It's the difference between the total revenue and the total cost. And you can see that if we look at this part of the graph, this would actually represent a loss. So anything within this area is going to be loss, anything within this area is going to be profit. We can also see that the difference between the total cost and the fixed cost is going to be the variable cost. Now the only drawback of a break-even chart is it doesn't show you the actual individual products, so we can't see anything to do with footballs, baseballs or rugby balls. A profit volume chart is going to help us out here. So a multi-product profit volume chart is going to plot each of the products individually. So we can actually see visually their profitability and we can compare each product with each other. We're going to actually plot the products in order of their contribution to sales ratio, and we're going to start with the highest and work through to the lowest. In lecture example 4, we're going to sketch a multi-product profit volume chart for the detail again in lecture examples 1 and 2. So we've got some partially completed workings so that we can actually get our workings ready for this graph. Now, we said we're going to plot in the order of the CS ratio. So the first thing we need to do is calculate the CS ratio for each of these products. Remember, the CS ratio is just the contribution as a percentage or a proportion of the sales. So the contribution for the footballs is 14,000 minus 6,000. So the contribution here is going to be 8,000. The baseballs is going to be 24 minus 18, which is 6, and 12 for the rugby balls. So to work out contribution as a percentage of revenue, 8 over 14 is 57.1%. If we do baseballs, that's 25%. And 12 over 27 is 44.4%. So we're going to plot footballs first, followed by rugby balls, and then finally baseballs. And that's the order of their profitability. So down here, we've actually got that reproduced in the order of those rankings. So this time, we're going to actually work out two different things to plot onto our graph: cumulative revenue and cumulative profit. This is the multi-product profit volume chart, you can see that it is slightly different from the break-even one. We've got profit or loss at the side this time on the y-axis, and the x-axis we've got cumulative revenue. So if we put this revenue on in the order that we've ranked it, we start off with 14,000 after we've sold the footballs. Once we've sold the rugby balls, we've got another 27,000. So that will bring it up to 41,000. And then by the time we've sold the baseballs, we'll be up to 65,000, which is the total that we've got here. Now the cumulative profit, we need to be a bit careful here because we're looking at profit, and that means that we're going to start off with fixed costs. And the fixed costs were 20,000. So by the time we've actually sold the footballs, we would have earned 8,000 in contribution. So we'll still be in a situation where we have a loss of 12,000. Once we've sold the rugby balls for 12, that's going to bring us back to 0. And then finally the baseballs are going to bring us into profit of 6,000. So let's draw this onto the profit volume chart. We're going to start off with 0 because when we sell nothing, we're going to have minus 20,000 loss. And the next plot point here was when we sell cumulatively 14,000, there is still a loss of 12. So that's going to be round about there. When we get cumulative revenue of 41, we're on to 0. And 65, we make a profit of 6,000. So that's roughly where the points are going to go. What we now need to do is join them up. Okay, now what you should see looking at that is that the gradient of the line is getting progressively less steep. That's because for every increase in revenue that we have, we're having less profitable products that we're actually making. So the footballs were the most profitable. So as we increase our revenue, our profit is going to increase by much more than our baseballs that were much less profitable, shown by a much lower CS ratio. So these graphs will tell us about profitability. And I've just put some labels on there. Now, one other thing that we can do with this graph is we can show the multi-product break-even point. If we draw a line between the two ends of this graph, where it crosses the axes is actually the multi-product break-even point. And that should be at cumulative revenue of $50,000, and we calculated this earlier on. That contrasts with a break-even point here when we actually sell the products in the order of their profitability. So when we've got $41,000 cumulatively, we'd break even if we actually sold footballs, then rugby balls. But because we're selling a mix, then the baseballs bring that break-even point. They actually raise the break-even point up to 50,000. Section 4 is about the impact of risk and uncertainty on break-even analysis. When we make assumptions during this analysis about costs and revenues, they're all estimates, and therefore we can't predict them with any degree of certainty. However, if we're lucky enough to have some past experience, what we may be able to do is assign some probabilities to the different outcomes that may occur, and if that's the case, the decision is said to be subject to risk. Using probability analysis and normal distributions enable risk to be accounted for. Sensitivity analysis, on the other hand, is a technique that will help us deal with uncertainty. This is where we've got no past experience, so we can't actually quantify any probabilities, and we need a different way of handling sensitivity analysis. Sensitivity analysis is a technique where decision options are tested for their vulnerability to changes in a variable. Now, one slight drawback of the technique is that you can only look at one variable at any one time, and in reality more than one variable may change. Now, there are two approaches to sensitivity analysis. The first one calculates the maximum percentage change in a variable before the decision would change. The second one assesses if the decision would change if a variable changed by X% of the estimate. Now, the usefulness of sensitivity analysis is that it concentrates management attention on particular variables that are most important for the decision under review. So if we came out with a low percentage, it actually means that it's actually quite highly sensitive to that particular variable, and management therefore need to keep a close eye on it. So lecture example 5 applies some sensitivity analysis to break-even. So let's look at the scenario. Columbus makes and sells a single product, the Rally. Financial data concerning this product is as follows. So we've got the selling price, the materials and the labour costs, and fixed overheads for the month are expected to be $30,000. Anticipated sales are 750 units. Some uncertainty has now arisen over the level of likely cost expected in the production of the Rally. So the first thing we've got to do is calculate the impact, so in other words the change on the margin of safety if material costs increase by 5%. Now, in order to work out the impact on the margin of safety, we need to know what the margin of safety is at the moment. And in order to calculate that, we need to calculate the break-even point. So let's start off with that. So the current break-even point then will be the fixed costs, which are $30,000, over the contribution per unit, which is the selling price of $120, minus the materials, minus the labour. And that gives us a break-even point of 462 units. Now, the margin of safety is going to be the difference between what they budget to sell, which is 750, and the break-even point of 462, which is 288 units. So let's just leave it for units, as units for now. Now, we're told that materials is going to increase by 5%. So if we up the materials cost by 5%, we end up with $31.50. And of course, that means that the contribution is going to be reduced. So the revised break-even point is going to be 30,000, and this time we're going to take off 31.50 rather than 30. So labour is still the same, and that comes to 473 units. So the revised margin of safety is 750 minus 473, and it's now 277 units. So we need to calculate what the impact is. So it's gone from 288 to 277. So that means that we have got a fall of 11 units. And as a percentage of the original 288, that's actually 3.8%. Part B uses the other approach to sensitivity analysis, so we've got to calculate the maximum percentage increase in fixed costs possible that will still allow Columbus to break even, assuming that materials is now still just $30 a unit. So basically we need to know how much contribution are we going to earn when we sell 750 units, which is our budgeted volume. And at 65 per unit, that actually comes to a contribution of $48,750. Now the fixed costs at the moment are 30,000. So you can see there is a profit situation at the moment, and the fixed cost could actually go up by another 18,750 in order to get to a situation where we were going to break even. Now 18,750 as a percentage of the current level of fixed cost is a 62.5% rise.